Hi guys, this is section 3.3, which is solving equations with variables on both sides. In the past couple sections, the variables are either on the left or on the right, but now you can see that it's going to be on both sides of the equal sign. So I want you to do the first step again, is to still draw the line down the equal sign down the middle, so that you can see you have variables on both sides. And again, it's the same rule. Whatever you do to one side of the equal sign, you need to do to the other. So you have to balance it off. What I want you to do is to take care of your variables first. We need to move the variables to one side or get rid of them out of one side and just put them all on the other. In this case, if I were you, I would minus 6x from both sides. You could minus 8x from both sides because you have 8x here, but if 6 is smaller for me, I like to get rid of that one um, because 6x minus 6x is 0. So now basically I just have it all on the right side. I drop down the positive 3 since there's a 3. And I don't need to write the equal sign for a positive 3. I can just write a 3. 8x minus 6x is 2x. Drop down the minus 21. Okay, be careful with the signs. On the left side of the number, you got to take that down as well. So you can see I took down the positive 3. I need to take down the negative 21. Now I have a two-step equation that you should be used to seeing. So I need to get rid of the 21. Since the 2 is next to the x, I got to get rid of the 21. So I'm going to plus 21 to both sides, or add 21 to both sides. This becomes 0. 3 plus 21 is 24. That equals to 2x. And now I need to get x by itself. So since it's 2 times x, I need to divide by 2. And this becomes 12 is equal to 2 divided by 2 is just 1. So x is equal to 12. I'm going to do a bunch of other examples for you guys as well. But that's how I want you to do it. Draw a line down the middle. Take care of one of the variables on either side so that the variable only ends up on one side of the equal sign. And then do your two-step problems. Here's how you write and solve an equation. So for 5 hours of work, Pono's Pizza pays Malia $56 plus 25 cents per delivery. Whereas Parker's Pizza pays Keanu $50 plus 75 cents per delivery. So you can see one, they start with more money but get less per delivery. This one starts with less money but you get more per delivery. After how many deliveries will they earn the same amount? So I need to write two equations, or one equation, I'm sorry. So I'm going to put Pono's on this side. 56 plus 25 cents per delivery. So it's just saying 0.25 times x. X is the number of deliveries. Okay. So when I do Parker's Pizza on this side, it's 50 plus, because $50 is constant, plus, and 75 cents per delivery. So 0.75. When I draw my line down the middle, you can see that I have variables on both sides. So again, take care of the variables first. So I need to get rid of either this one or this one. In this case, I'm going to minus 0.25x. Minus 0.25x. Notice I'm doing it right underneath the x's so they line up. I'm not doing it under the 56. That way I know I can cross that out. That becomes 0. I can drop down my 56. And instead of writing it here now, I can move the 56 a little closer. And then I get 50 minus, I'm sorry, 50 plus, excuse me. And 75 times minus 25 is 0.50x, or 0.5x. You can drop the 0 after the 5. Now I can see I need to get rid of the 50, so I'm going to minus 50. And get rid of it. So when I go 56 minus 50, I get 6 is equal to 0.5x. Now you can divide by 0.5, which is the same as dividing by 1/2. And instead of dividing by 1/2, I can multiply by 2. Remember, I can multiply by the reciprocal. This is a divide by sign, sorry. Okay. So another way to see this 0.5 is I could write it as 1/2x. And if I write it as 1/2x, I could multiply both sides by 2. And then get 12 is equal to x. So what it's saying is at 12 deliveries, they would make the same amount. But after that, for everyone after that, since Keanu's making more per delivery, Keanu would actually make more. Okay? So that's how you write and solve an equation. The next section I wanted to show you was special cases. So we have identity and we have no solution. That's the two special cases. The first two examples I just did, there were solutions. You came out with an answer, x equals something. In this case, I'm going to show you what this means. Again, draw a line down the equal sign. You can see that this is not simplified. I need to distribute the right side. So I'm going to circle one rainbow and distribute. I'm going to drop down to 10 minus 8a equals, and when I do this first rainbow, 2 times negative 4a is negative 8a, and then 2 times positive 5 is plus 10. Okay? And here's why I tell you to take care of the variables first. I have a negative 8a, negative 8a, so either side, if I add 8a to both sides, whatever I do to one side, I have to do to the other. This becomes 0, this becomes 0. I drop down my positive 10. Again, a mistake people think is because there's a minus on this side, it goes with the 10. You got to take whatever's to the left of the number. And so if there's nothing there, it's a positive 10. And it equals, and there's a positive 10 here. You can say 10 is equal to 10. Once you come down with a number equal to a number, that is called an identity. What it's saying is this side is equal to this side. It's identical. And if I added the 8a back in, if I had this part right here, if I just rearrange it, 10 minus 8a, and I said 10 minus 8a, you can see it's the same thing. It's an identity. So no matter what number I put into this, if I had 10 minus 8a is equal to 2 negative 4a plus 5. Back to the original problem. No matter what number I put here, if I put a 0 here, 10 minus 0 is equal to, and if this is a 0, negative 4 times 0 is 0 plus 5. So 2 times 5 is 10. So 10 was equal to 10. And what it's just saying, basically, I know that was hard to see, but no matter what number I put in for A, I could put 10 in for A, or I could put 100 in for A. It would still come out the same because this side is equal to this side. So it'll always be true. Okay. The other one would be a no solution. So on the right-hand side, I have a no-so here. And what I want you to do again, draw the line down the equal sign. And I can see the reason why I want you to do that is because here's a common mistake people make. They see this and they go minus 2m, minus 2m. And you can see it's on the right, the same side, the right side of the equal sign, so you cannot do that. Or somebody else does this. They put minus 2m on all the m's. And that doesn't work as well because you can see I'm only minusing 2m over here, but I'm minusing it twice on that side. So that's the reason for that line going down the middle, to help you balance. Okay? So what you want to do is when you draw the line down, you can see I need to simplify this right side. So I need to combine like terms. So I'm going to have 6m minus 5 on this side. When I combine this, 4m plus 2m is 6m plus 7. And another reason I want you to do the variables first. When I minus 6m from here, and I minus 6m from here, this becomes 0, this becomes 0. I drop down to negative 5, and I drop down to 7. Okay? Negative 5 will never equal to negative 7. And so my answer would be no so. Okay, no solution. What this is saying is no matter what number I put in, if I have 6m minus 5 is equal to 6m plus 7. If I took this equation here, no matter what I put in for m, it'll never be true. If I put a 0 in there, I would get negative 5 is equal to 7. That would not be true. I could put any number in there and it'll never be true because there's no solution. Okay, so special cases is identity, which means any number could go in for that, or that both sides are equal. No so, there would never be a solution for that. Or the examples that I used before had one solution. So here's just a quick recap of what I'm talking about. There's going to be 3 types of equation. One that has a solution, an identity, or a no-so. It's only one or the other. It will never be more than one. So if it has a solution, it is not an identity, and it is not a no-so. If it's an identity, it will neither be one or the other. Okay, so in this case, real quick, if I minus x from both sides here to get rid of that 0, I get 5x minus 2 is equal to 13. If I plus 2 to both sides to get rid of that, I get 5x is equal to 15. Divide by 5, and x is equal to 3. There's my solution. I have a solution. Okay. Whereas this one, if I circle and distribute, and I get 4x plus 12 is equal to 4x plus 12. If I minus 4x from both sides, I get 12 is equal to 12. There's my identity. Okay. And my last example, if I draw a line down here, I need to distribute this, and I get 3x minus 15 is equal to, and if I combine this side, 5x minus 2x is 3x minus 1. When I minus 3x from both sides, I get 0, 0. I drop down the negative 15 is equal to the negative 1. That is not true, so my answer would be a no-so. Okay, so you're either going to get a solution, or it's an identity, or it's a no-so. Okay, please don't put x equals 3 identity or x equals 3 no-so. That's not true. You're only going to get one or the other. Okay, that's 3.3. I hope this helps. Take care.